Well, good morning, and certainly welcome to the session on Hearing Loops, the Basic. We appreciate your attendance. We're glad to have this kind of turnout to share information with you. And I want to remind you right at the beginning that I've been told the entire session will be available online, so note-taking may not need to be as heavy as you would otherwise do, since you'll be able to find the information online afterwards. My name is Andy Jankowski. I'm the business manager of Assistive Audio. And for the last 12 years, we've been very proud and pleased to be the sole distributor for Amptronic's line of induction loop amplifiers into the U.S. market. During that time, with their cooperation and assistance, and the strong advocacy that we get from groups such as the HLAA and individual members working on systems and working on applications in their areas of the country, we've been pleased to be able to place Amptronic equipment at a variety of locations. Many of those are in the traditional market that you're familiar with, being the worship market, meeting rooms, auditoriums, and such. But we've also been able to be successful in introducing loop systems into new venues, which I think expands the entire concept, such as subway systems in New York City, taxis perhaps, many more museums than there have been in the past. So we thank you for your work and your advocacy in assisting to bring that about and allow that to happen. Without any other delay then, I'll pass this on to Ken. Ken Hollands, the International Director of Amptronic, is going to start the program and go over the basics of the loop systems.
Good morning, everybody. I'm delighted to see so many people here, having worked with induction loops for some 6 years, 8 years. And in the US, that is, and having such small participation from the US in the past. It's so encouraging to see so many people here today. First of all, I'd like to explain to you how induction loops work. What we have here is a guy, a bit like me, I suppose, speaking into a microphone, a very directional microphone. That should be picking up just my voice and filtering out all the background noise, the noise from air conditioning units, other people speaking and so on, feeding a nice clean signal into an amplifier. That amplifier happens to be a current amplifier, and we'll talk about that later. That current amplifier drives a current through a cable. The cable is placed around the audience in its simplistic terms. That current sets up a magnetic field, which in turn induces a current into the pickup coil of the hearing aid. The current is being modulated by the person's voice. So we've got this modulated signal, an audio signal, fed into the pickup coil of the hearing aid. That signal is then going to be tonally corrected for the person's hearing loss, amplified, and via a speaker fed into the person's ear. And that's simply how an induction loop system works. This is an illustration of the magnetic field that we can expect to see from a perimeter loop. The most important thing to get from this particular diagram is that we're only interested in controlling the vertical component of the magnetic field. The T-coils in your hearing aids should be mounted vertically, and it's only that component that we are controlling and trying to look after when we look at induction loop systems. So where can induction loops be used? Essentially in any position where there is a need for one-to-one communication. You can see here we're illustrating a car park application. It just so happened when we did our feasibility study in this car park, there was a building site next door. And at that building site, they were driving concrete pylons into the ground. It was a very noisy environment. And as we demonstrated the system to the facilities manager at the car park, the only person that could hear what was being said on the intercom system was the person sitting in their car listening to the induction loop system. The rest of us had absolutely no idea. And it was a very nice illustration to facilitate the promotion of induction loop systems. Other applications then where induction loop systems are being used in the transport environment. In Ireland, we have loops on the trams, on the Dublin network, at airports, subways, train stations, and so on. So other applications for loops. Throughout the world, in fact, we have induction loops at universities, theatres, conference centres, cinemas. In fact, churches such as Westminster Abbey, the royal wedding was covered by one of our systems 2 or 3 months ago. And of course, we can use induction loop systems in our own homes. And in our own homes or offices, we can connect audio systems from microphones, TV systems, video players, and so on, and including telephones and alarm systems. Where are hearing loops not suitable then? Hearing loops are the first choice for assistive listening in all of these applications. In some cases, they're the only option. If we have what we describe as a transient environment where people are only going to be there for a few minutes, it's not feasible, it's not practical to issue them a receiver to use that system for those few minutes that they're in that facility. So currently, the only option we have is to use induction loop technology. However, places where they shouldn't be used. If the background magnetic noise is too high, there's absolutely no point in installing an induction loop system. So the first thing we're going to do before we install or recommend an induction loop system is to make sure the background magnetic noise is not too loud. Not too loud. The next reason that we would not use an induction loop system is if we have a secret meeting. Induction loop or magnetic fields will transmit outside the room, and as such we cannot hold a secret meeting using an induction loop system, in which case we have to resort to infrared. This is some simulation software that I'm going to use to describe some of the other issues with induction loop systems. What you should take from this picture is that green is good, so that's within the standard that we're trying to achieve. White to yellow is too loud, and red to black is too quiet. So when can't I use an induction loop system? Well, if my induction loop is placed in too close a proximity to the listening plane, such as at ear height, I will not get an even field across the space. What I need to do is make sure my loop has sufficient displacement from the listening plane. If we look at this illustration here, we can see in the centre of the room the signal is too quiet, yet towards the edge of the room the signal is too loud. And that's because our loop is too close to the listening plane. By moving the loop further away from the listening plane, so perhaps taking the loop up 3 metres in the air, into the ceiling, then we can get good even coverage with the perimeter loop system. If we've got adjacent rooms, we need to be careful about using perimeter loops. If we've got a perimeter loop, the spill field from a perimeter loop is roughly 2 to 3 times the width of the loop, such that if we've got 2 adjacent rooms, the 2 systems will interact with each other, in which case we need to use low spill technology to control the spill in the 2 adjacent rooms. In this situation, I cannot use an induction loop system either, where we've got metal structures in the building. The metal structures will absorb our signal. So those metal structures might just be the metal ceiling tiles, or the construction of the floor, maybe reinforced concrete and so on. And that reinforced concrete, that metal, will absorb our signal. In which case, we need to be very careful about the placement of perimeter loops. If we do have metal structures, we need different technologies or different loop configurations, such as figure-of-8 type arrays or phased array systems. And I'll talk about those later on. So when can I install a perimeter loop? Here's a rule of thumb. You'll find this on Amplitronics' website. There's also a Designing Loops handbook that you could download from our website. And on that, it'll give you an idea as to where you can install a perimeter loop. What we can see from this table is different building types, different construction types. Where there is no metal in the building, we can have loops at or cover areas of 22 metres wide, maximum. Where we've got moderate mesh, then we have to limit that coverage to 5 metres wide. And when we have heavier metals or more metal in the building, the width of the loop gets narrower and narrower. So if a perimeter loop isn't suitable, what do we do? We've got different loop configurations that we can actually use. I'll take you through those loop configurations now very quickly to describe where and when we would actually use them. The first loop then is an overspill loop. If you're looking at a counter, then it might be that you need to get good coverage at a counter. In this case, we can see the green line here is our loop. That loop is vertical, it's a preformed loop, it's about 1 foot square. And providing that's in the counter and it's displaced from the listening plane, we can get good coverage at that counter. You should note that in the centre of a overspill loop or a counter loop, there is no signal. And you can see from this illustration, there is no signal. I should also mention to you, just to confuse everybody, the colours here are different to the colours on the previous slides. It's older software that we've used to generate these images, in which case a good signal is actually yellow and a poor signal is black, blue, red. It might be that we just want to control the spill field in one direction. This particular example was something that we did for a doctor's surgery. So we've got a doctor's surgery here, we've got medical staff here, here, and here, and this is a waiting room. Of course, we weren't too worried about the medical staff overhearing what was being said in the doctor's surgery, but we were very concerned about other patients in the waiting room overhearing what was being said. By making a simple cancellation loop, which is just a figure-of-8 pattern of wire, we can control the spill in one direction. This is a very simple, cheap, cost-effective way of controlling spill in one direction. And if that's all we're trying to achieve, it's a good solution. A figure-of-8 array is something that we would use to compensate for metal loss, because we can use much narrower loops. If you remember from the table that I showed you that was in here, to cover large areas or to cover or compensate for metal, we need much narrower loops. A figure-of-8 is a simple way of doing that. It's just a figure-of-8 pattern, and it will give us good coverage. And we can use that type of approach where we have fixed seating. As you can see, if we arrange it such that the coverage is in these areas, where the two wires are running parallel to each other, there is no signal. If we keep that in the aisles of the venue, then we can ensure that we get good coverage where people are seated. Perhaps, sorry, was there a question?
On the last slide, can you explain what keeps it from flowing, from spilling over to the right side there, where you have the figure-8?
Yes, essentially we have the magnetic field or magnetic flux from this loop is in the opposite direction. If you remember my diagram of magnetic flux, I had these circular circles with arrows pointing downwards on one side, and on the other side they were pointing in the opposite direction. So in that way, if they're both pointing down, they add up. If one's going one way and one is going the other way, they're in antiphase and they cancel each other. And that's what we're having here. We've got cancellation of the two magnetic fields from the different areas.
When you're actually laying this down, you're going to go like a snake pattern and then come back up. And anytime you've got the loops together, then you don't have any coverage, is that correct?
Exactly. So if you see here, where the cables are running in parallel with each other, you can see there is a cancellation effect. So where the two cables run together, you need to keep those cables in the aisles where no one is going to be seated.
Okay, I'm sorry, that is one wire, right?
Yes, it's just one continuous piece of wire.
Considered one loop.
Yes, it's literally, it makes a figure of 8 pattern.
Okay, thank you.
So draw the number 8 and you'll see how it works. In some situations, of course, we don't have fixed seating. But we still have issues with metal loss, we still have very large areas that we want to cover. In those situations, we need another technology to help us cover those spaces uniformly, in which case we can use phased array technology. A phased array looks something like this. This is one arm of the array. The blue line there is the perimeter of our room. The pink line is one pattern of wire. It's one arm of the array. We actually need to install another pattern of wire, the second arm of the array. So we have two patterns of wire that sit on top of each other. And that's why when you were in the ballroom yesterday evening, you saw lots of cables going across the room. And that was, or is, a phased array system. To get that system to work correctly, we need to drive those two separate loops with two different amplifiers, but we also need to put what we call a phase shift between them. That phase shift means that we can get good even coverage. If people want to ask me about phase shift technology afterwards, I can explain it to them. I think it might be too much detail to go in at this sort of basic session. But suffice to say, if we use two patterns of wire, put a 90 degrees phase shift between them and drive those elements, we will get a nice uniform field over the space that we're trying to cover. We will still have some spill, but in this case the spill field is about 1 times the width of the room. So a perimeter loop spills 3 times the width of the room. A standard phased array system spills about 1 times the width of the room. Where we want to have adjacent rooms covered, we need to up our game in terms of the technology that we use or the designs that we use, and we work with ultra-low spill technology. And that, from other manufacturers, is referred to sometimes as a super loop. Amplitronics' version is ultra-low spill, and that will control the spill to within 1.6 metres of the width of the room, sorry, of the edge of the loop. So we can now, using ultra-low spill technology, we can put a loop in this room and have a loop next door without the concern that they will spill into each other.
Is that one loop in that room?
No, that is 2 separate loops. It's this.
Still a phased array.
It's a phased array. It has to be a phased array system. For an ultra-low spill system, we just pay more attention to the design of those of the position of those cables, such that when they are installed, they're installed to a tolerance of plus or minus 10 centimetres or 5 inches. As long as we install them to plus or minus 5 inches, we will get the performance like this. I was asked to explain the advantages and disadvantages of voltage and current drive amplifier or current drive technology. So I'm going to go through some of the theory very quickly and then talk further about the pros and cons of the technologies. First of all, you need to understand that the magnetic field, which is what we're interested in generating this strong magnetic field for the T-coil, is proportional to the current in the loop. So we're trying to get a constant current in the loop to generate that good magnetic field. The loop impedance or the resistance of the cable is dependent on its length. But the loop impedance is also dependent on the frequency. Now, anyone that's been to sort of electronic school will know the equation V equals IR, which is Ohm's law. And that's telling us that if the current in the loop from a constant voltage source will actually change with frequency. and it will also change with the cable length and the cable type used. So with a voltage source, our current is is determined by the length of the cable. It's also determined by the frequency. So we do not get a nice, even magnetic field naturally from a voltage amplifier. We have to do other things. Whereas with a current amplifier, it's a constant current amplifier. It's giving you that constant current. So put it in very simple terms, it's actually easier to design an amplifier capable of driving multiple types of loops, different types of cable, with different impedances and so on, using a constant current drive. So again, what is best? Is it voltage drive or current drive? Well, I don't actually think that's the question. It's what has it been designed for? So I've got some knives here, I've got some bread. I could cut the loaf with any one of these knives, I'm sure you'd agree, but using a bread knife would be easier, safer, and consistently give me better results. So in this case, it's what it's been designed for. It might be that you've spent something like $5,000 on an amplifier which was designed to drive speakers. Yes, you could convert that into an amplifier to drive a cable, a current loop, sorry, an induction loop. But it's going to take you a bit of time to make that adaptation. So it's actually better to buy a piece of equipment that's been designed for the job. I am showing here a current drive amplifier. Of course, you could have a voltage drive amplifier that's been designed specifically to drive a loop. Voltage versus current drive. So what is the question? Well, for me, the question is, does the installed system meet the performance standard of IEC 60118-4 2006? That's the question. If it does, you can, with confidence, you can expect the system will provide a benefit to the users. So who really cares whether it's voltage or current drive? That's not the point. The point is, does the system, the whole system, meet that standard? Now we're going to talk about how you would set about installing a perimeter loop. Before you start that process, you need to make some basic checks. You need to check that the background magnetic noise is sufficiently low that an induction loop system will work well for you. If it doesn't, there is no point in installing a system. You need to check that the perimeter loop has been correctly designed for the space that you're trying to cover. If you remember, we talked about loop position with respect to the ear height. If you cannot get far enough away from the ear height to get even coverage, then you cannot use a perimeter loop. You need to check that the perimeter loop is capable of coping with the amount of metal in the construction of the building. You need to check that the amplifier you're about to use is capable of driving the cable. It's no point using a very small amplifier to drive a very large system. You will not have enough power there to generate enough current and enough magnetic field or field strength. You will also need to check that there is a suitable location with power outlets in which to install your amplifier. So with those things in place and with the correct tools, you can set about installing a perimeter loop. I'll hand you over to Andy, who's going to talk to you about how you go about doing that.
Thanks, Ken. The three components that you're going to have in putting a loop in at your home, for example, to hook your TV in up to, is going to be the loop cable itself, the amplifier that's going to drive the signal through the loop cable, and then certainly an audio source that you're going to be working with. So the loop cable and the loop wire that's used is really nothing special. It would be something very similar to this, which is just an 18 gauge, which is the size of wire, single conductor, stranded copper, to give it some flexibility and ease of use. When you install the loop wire through your room, as you can see illustrated in the picture here, you have the option of putting it at floor level, or perhaps at ceiling height. Those two positions of the loop wire really give you proper displacement or distance from the listening plane when you're seated typically. So you're going to maximize the signal strength or the benefit by placing the wire in one of those two positions. It can easily be done doing that going along the baseboard. If you do have a basement and a wood floor, you can actually go underneath the floor and attach the wire to the joists in the basement, defining the perimeter or the outside extents of the room that you want to enclose or provide the loop system in. If you do have, and as it shows in the red line, which is illustrated here, you do not need to necessarily tackle getting the loop wire across door thresholds or accommodating it that way. You can run the loop wire up above the door frame itself, and that short displacement of the loop wire from the listening plane really isn't going to affect the performance of the system to any great degree that will take away from the enjoyment or the use of it itself. You want to, yes?
I have a question about ceiling height.
Mm-hmm.
Is there, there are a lot of places that have the high ceilings now. Is there a distance that's too far where you shouldn't use the ceiling?
There certainly can be. The further away that the loop wire is from that listening plane that we were talking about, ear level in a seated position, certainly you're going to then be required to drive that signal further from where the position of the loop wire is installed to that listening plane or to ear level. The optimum situation, since in seating it's about 4.5 feet from the floor when one is seated, you'd be wanting to work with a 9-foot or an 8-foot ceiling from that standpoint to remain that optimum situation. If you do have to go much higher than that, and I'm sorry I can't give you any exact dimension on how high because it's then determined by the other dimensions in the room and what kind of or what size amplifier you're using to do that, you're going to have other considerations to be able to bring that signal down.
Can I just...
Certainly.
We were asked to put a loop in Westminster Abbey, which I showed you a picture of before. They wanted to use a perimeter loop and they wanted to cover the whole of the Abbey. The problem was that the Abbey is very tall. And to use a perimeter loop in the Abbey, we were going to need 80 amplifiers to drive it. So whilst you can do it, you can go to whatever height you like, you need more and more power. So it does become, you get to a point where it's not practical, and that's why you have to start looking at those other loop configurations that I talked about.
What about a room below and a room on top? How would you design that? Both rooms capable of looping.
Well, if you don't mind the spill that Ken was talking about earlier from one end to the other, then there really wouldn't be any issue from that standpoint. The spill that comes off of a loop system is going to go in all directions. So in your illustration or question, it would spill up and it would also spill down as well as out. So if you were wanting to use concurrent or different programs in each one, we would have to look for a way to separate the two loops that would be put in each of those areas then enough to minimize the spill into the area from the other program, if you will. In that case, you may use the floor on one level and the ceiling on another. And you may need to also consider a different loop pattern other than a perimeter loop that would allow you to have a narrowing of that loop pattern which would minimize the spill as Ken was illustrating earlier in his examples. Is that okay?
You haven't said anything about polarization, and I have a situation in the church in one room where there's a polarization. You can turn your head from one way to the other and get a different amplification from the loop.
There's orientation of the telecoil and the way in which the signal induces the telecoil has a great deal to do with your question, I believe. One of the early slides that Ken was showing regarding the magnetic fields, it looked a little confusing from the standpoint of seeing how the magnetic induction comes off the wire, is what actually works to induce the telecoil in your hearing aid. if the magnetic field is able to induce the full length of the telecoil as it's positioned, you're going to get the maximum amount of pickup or induction into the telecoil itself. As you turn your head, based upon how the manufacturer of the particular hearing aid that you have has oriented the telecoil in that unit, you're going to change how that signal induces the telecoil. And with significant changes in the position of that, you can reduce the amount of induction into that so that you could have cut out of the signal at some times, or you could have something that varies from that. That may be a very general answer to your question, sir, without knowing more of the particulars about it, but it sounds as if you were addressing an orientation issue, where if you're stable or if you're saying in one position the signal is satisfactory, but as you're turning, it may change. The polarity of the loop itself has to do somewhat with the last portion here. As we take the cable and we start our run into the room, we call that the run cable. That run is going out away from the amplifier then, and the wire, as you continue it to close the loop, coming back is called the return. The current will flow in that direction, run back to return. Now, I don't know, but just to further answer your question or address it perhaps, as Ken was showing some of the different loop configurations earlier, and he was talking about the polarity of the signal, both coming in the same direction, being an addition, or being in opposite directions, then being a cancellation, that may be another reason why, in your particular case, some areas seem to vary. There may be some cancellation happening because of the loop pattern itself. Be glad to address that or talk to you more specifically about it afterwards if we could. But what we do when the wire...
It's not the loop, it's the hearing, it's the column
Okay.
that is the problem.
So it's the telecoil.
Yeah,
Okay. All right, loops, Ken is just saying that the problem is most probably the orientation of the telecoil in the hearing aid. To finish on this particular slide, as we come back with that wire, the one continuous run, and the return comes back, we close the loop area by twisting the two wires together. That's just an indication to the amplifier that the wire that is going out prior to that closure is in fact the loop area that the signal will be present in. The other component is the amplifier itself, as we talked about, and there's some general standard procedures and things to remind you about regarding setting up or using and connecting the amplifier. And the first would be with the amplifier turned off. With the amplifier off, connect your loop wires to the amplifier appropriate for the model and for the connection that's provided, so that you have your loop wire connected to the amplifier as the first step. The second step would be to connect your input, your audio source, with the appropriate cable from the audio source that you're collecting that from, be it your TV, your stereo, a PA system, in a larger application such as we've encountered here during the meetings, the mixer panels that the audio-visual people provide. So the audio input is collected and plugged into the amplifier next. And again, during that time, that input should not be producing any sound. You would like that to be off also. Next, you want to make sure that when you do set up the amplifier before you start using it, that you have all the controls that determine the strength of the signal as it comes into the loop area turned off or set to a minimum. And then finally, connect the power source to the amplifier itself. So the power cable going into the amplifier back should be the very last step that you have in the amplifier component of setting up a home loop. And then after that, turning on the amplifier and following the setup procedures associated with the amplifier from the manufacturer. I'm sure that all manufacturers provide a manual and a document that is somewhat similar to the one that I'm holding up here. Us men want to move on very quickly and usually kind of try to skip this step. and we find out later that that is something that we shouldn't do. And usually it's the wife that reminds us that we shouldn't have done that. So I encourage all the women in the room to continue to remind their husband to stop and read the instructions beforehand. That's a very good and beneficial step. So setting up the particular amplifier model that you have according to the instructions from the manufacturer is very important to do. After that, we want to collect the audio source that we want to tie into the loop in the house, and that's looking at, and the one that we've done and we've been asked to cover is a television. Televisions can offer a variety of inputs, especially the newer models today. So without getting into too much detail of that, we're going to cover the older type models as well as some of the general characteristics of the new units also. We're looking for what is called an analog signal. The induction loop amplifier is going to look for an analog signal coming into it. Analog signals based on TVs are typically going to be identified under a section on the back of your TV noted as audio out, and it will most probably be an RCA or a phono type connector. So we have an illustration of those as you see here in the top section of this schematic here. Audio output, besides being labeled as audio out, can also be indicated by this little symbol, which is a circle with a line in it. And I believe the intent of that was to indicate a connection or an audio connection portion with a line coming out of it or a line out, meaning this would be a line out connection or something that would be appropriate to tie the device into the induction loop amplifier. Now, the newer TVs may offer, in conjunction, may offer an analog out for your convenience and use with other devices, but many of them have gone to a digital or an optical digital audio output. So when you see something on newer TVs under the audio out section that may look comparable to this example that we have on this slide, then you're going to need a different type of device to be able to connect your TV to the amplifier. We have to have something that goes in between the TV and the amplifier to convert the digital or the optical signal back to an analog signal that the amplifier can utilize. So there are different models of that, but you would be looking for a digital to analog converter in that case. And this is just an example of one that we found and would be appropriate for use. The way that that would happen then is you would connect the digital output from the television via a different type of cable that is called a TOS-link cable. TOS, I believe, standing for Toshiba, so this may be technology that they developed, and hence the name for the cable itself. But that would be from the digital connection of that going into and using that as input into the converter. From that, then the two connectors that you see on the bottom of the conversion device is going to take you back to that RCA cable or phono type cable that allows you to make an easy connection then to the induction loop amplifier. So if you do have a newer TV, and it's very important to check what kind of audio out opportunities you do have from that device, you're able then to either go directly into the induction loop amplifier, or you may need a middle piece that does a conversion from a digital signal back to an analog signal for you. We've covered a great deal of material, and especially on the television aspect of it, I understand that you may be sitting out there with many questions. We do have a time constraint that we need to deal with here, and we want to allow some time for questions after the summary. So if you do, please come up. We have an example of an amplifier with some audio cables that are connected to that and some options showing what's on the back of the small TV here that will facilitate, hopefully, those explanations. So please visit us at that time or ask the question after that. We're going to work to summarize what we've covered today, and I'm going to turn it back to Ken to do that for us.
Thank you. Thank you. So we started off just by looking at how loops work. We talked about a perimeter loop, and I explained how the technology works in terms of driving a current through a cable and setting up this magnetic field that couples it into the hearing aid. The important thing to appreciate is that the T-coil in the hearing aid must be mounted vertically if our systems are going to give you the performance that you need. So that's one thing for the audiologists to consider, and the manufacturers of hearing aids to consider in working with the technology that we have. We looked at how or where hearing loops can be used, and essentially wherever there is a need for communication, so audio communication, there is a place for induction loop technology. So that might be one-to-one situations, it might be intercom systems where you have no idea, like in the car park situation, you have absolutely no idea what the background noise is going to be at the time you're trying to use the system, so you need an induction loop system to help. Or it might be a venue such as a church, a lecture theatre, or even a theatre like the Kennedy Centre, where I hope that people did enjoy the system that we put in there. We then talked about situations where perimeter loops. So we explained perimeter loops and how they work and what the limitations of perimeter loops are. So if the venue you're trying to cover does not allow for the perimeter loop to be far enough away from the hearing aid, you cannot get good even coverage, so you need to look at perhaps a different loop configuration. Or if you've got to compensate for metal, we explained that metal absorbs the signal, so you're limited in terms of how big that perimeter loop can be. We then illustrated some other loop configurations to enable us to cover these places, so to compensate for metal. We talked about figure-of-8 loops, which are great if you've got fixed seating. We talked about cancellation loops. If you want to just cancel the signal in just one direction, we can use a simple figure-of-8 type pattern designed specifically to cancel the signal in one direction. We talked about phased array systems, which, as I said, enable us to compensate for metal loss. And we also looked at ultra-low spill systems, which cancels the field to within 1.5 metres of the perimeter of the loop. Incidentally, an ultra-low spill system will also limit the spill in the vertical direction. So providing we have something like 4 metres, so that's 12 feet separation from one floor to the next, we can install ultra-low spill systems on sort of different levels. And then finally we run through the process of going about to specify and install a perimeter loop. We did not get into the design of a perimeter loop, that's for another day. We also then talked to you about how we might connect that to a TV. And one thing that perhaps didn't get mentioned with the TV situation is that there can be some synchronization issues with video and audio. There can be a delay on the video signal, which is something that obviously as a loop equipment manufacturer we're not in control of, and it does depend on the TV setup that you've got. What we did say, if you take the feed directly from the TV, that issue, whilst it may not go away, it's not nearly as a bigger issue as it can be. So if you take the feed from the TV, you're less likely to encounter this synchronization problem. Where you do encounter the synchronization problem, there are adjustments, certainly on the modern TVs, that enable you to adjust the delay on the audio. However, you need to speak to the manufacturers of the TVs because it's a function that is only available to the technicians, and they can adjust it for you and set it to generally 100 milliseconds or so, but it's something that the technician needs to do. It's not something that you'll be able to do easily on your own unless you're a technical kind of bod, I suppose. So hopefully you've gained something from this very quick introduction to induction loops. We do run seminars for further training on the internet, and the HLAA were kind enough to invite me to give a presentation on the technical basics of loops last month. However, we also run independent sessions on the web. The first will be starting in September of this year, and it follows this program. You've got sessions right from the very basics as to why you want induction loops, right through to system commissioning and compliance testing. If there are any questions, then we've got 2 or 3 minutes to take those questions.
I have 2 questions. The first one is, do you need to be an electrician in order to install audio loops? And the second one is personal. At the time, well, I cannot use my telecoil switch in my living room. And at the time, my husband deduced that it was because the living room was over the area of the basement where the electricity came into the house. Is there a way to overcome that problem?
To overcome the problem of interference from your basement, I'm afraid the short answer is no. Unfortunately, it would sound like the wiring is perhaps older wiring, and the only way to overcome that is to have your basement rewired. Generally speaking, with modern buildings, the cabling is done in such a way that you do not generate magnetic fields. If the cable, the supply and the return of your electricity supply run in the same conduit, the magnetic fields actually cancel, so you don't get a magnetic field. But in your situation, it would seem that someone has wired it such you make a loop, and so it's generating a nice 60 hertz in the US hum. So the other question was?
Do you have to be an electrician?
It depends. You need a certain amount of technical competence to install a perimeter loop in your house, certainly. But you won't need to be an electrician in the sense that you don't have to touch mains supplies. It does sometimes help, but for the bigger venues, it's probably more appropriate that you're a professional audio technician to install the big systems in the big venues like the theatres and so on.
I assume that loop systems are monophonic systems, and that brings up the question when you're dealing with TV or stereo output, or any kind of stereo output, how you sum the 2 sides of the signal together before you feed it into the loop amplifier. Do you have to do anything special, or can you use just a Y cable? How does that work?
Essentially, the amplifier will do the summing for you. So you can take your stereo signal and plug that straight into the amplifier that you're using. I mean,
it has two inputs. It has stereo inputs.
Would you hold that? Yes, yeah. Basically, it has 2 inputs to cope with that, and then it channels those 2 inputs into one single feed for the amplifier itself. So you don't need to worry about the stereo coming from your system. The amplifier itself will take care of that.
I've got a question on resistance on the loop. It's a current carrying loop.
Yes.
And if you have too little resistance, is there a possibility of damaging your amplifier?
An amplifier that's designed to as an induction loop system, you'll find that if your resistance or your impedance from your cable is too small, the amplifier will not turn on. It will give you a loop error, basically saying that you've got a short circuit. You'll find that on all amplifiers in the specification, it would tell you what the minimum impedance the amplifier can drive, or the minimum size loop it can drive, to the maximum size loop. And sometimes what we would do is actually put extra feed cable into the path to increase that resistance up to that minimum value. So sometimes you'll see in installations lots and lots of feed cable that looks unnecessary, but all it's doing is adding extra resistance so that the amplifier sees a load.
Thank you, Malik Al-Amin. You talked about getting a converter for newer televisions going into the amplifier. Yes. Is there any indication that amplifiers will eventually, the manufacturers of them will eventually be modified to be able to take a digital signal instead of analog?
At the moment, it's a case of supply and demand. At the moment, there isn't enough demand for digital interfaces on the amplifiers, so at the moment we have no immediate plans to do so, but I'm sure as we see more demand for such optical interfaces on the amplifiers, it's a relatively straightforward thing to do. It's just a costly thing to do, and if there isn't enough customers wanting it, it's not viable for us to do it. In the future, I think we can, or will.
I'm wondering if you've had any experience with looping classrooms that are both on top of each other and right next to each other, because it sounds like no matter what you do, there's some bleeding. So what happens, I mean, I understand you can go in the ceiling and on the floor, but if there's also on top and below, and they're next to each other, what happens then?
Okay, with the rooms adjacent to each other on the same floor, there is no problem with the ultra-low spill technology. For different levels, then there may be a problem. To illustrate this, we did some work for Dundee University I think 2 years ago. They had a new building that was being constructed, and that was a lecture building. And they had lecture theatres on each floor, adjacent to each other, and I think it was something like 10 stories high. They wanted total coverage of the whole facility. Now, what we did know is that they had 4 metres separation, so that's from floor to next floor, there was 4 metres separation, so some 12 foot. And on that basis, we know that, as a rule of thumb, that we can cover by using a loop on the floor of the first floor and a loop on the ceiling of the next floor, the two systems will not interact with each other. That's rule of thumb. Once we were able to go to the building, once it was built, we made some testing. And it just so happened that they were using computer metal system floors. And those metal system floors will absorb your energy. And the fact that those metal systems floors were absorbing so much energy, it enabled us to start putting loops not just on the first 2 floors and miss a floor, we could actually put loops on every single floor, on every single level. So rule of thumb is that you can put loops on the first 2 floors, then you have to miss a floor, providing you've got this 4 metre separation. Beyond that, you need to make some tests, you need to make some measurements. And then you're looking for the fabric in the building to absorb signal to enable you to give full coverage.
Does the home alarm system or microwave affect this system?
No. Not if it's been correctly installed.
Getting back to the TV situation, where you have the loop in the room, if you wanted to sit upright and also use a lazy boy, which is a recliner, then do you run into problems with the signal strength because you're at different angles to the loop?
Yes, you will have a different signal strength with a perimeter loop. If you had a phased array system in your room, then you might be able to lie down and watch TV in whatever position you like.
I have a loop receiver here, and up here there's a lot of hum. Down on the floor there's no hum at all. The cable in the back, right over, it's dead, but just coming out from it on the floor, it's probably the loudest. So it all depends on lots of things. So.
Yes, it depends on the facility that you're in as to whether you might have some interference. This is looks to me like a relatively older, at least sort of furnished room, and I would guess you're getting some interference from the lighting system in there. But I would think at seating level you're all okay. And of course, if you're moving outside the loop, this is not an animatronic system. This was installed by hearing loop systems, and I don't actually know what the design was. So it might be that they've got a cancellation loop, which means that if you're sitting towards the edge of it, the signal will fall off. So it depends on how this loop was designed to what you will experience. I think we've got time for just one more question.
Ken, going back to the lazy boy question, what if you change the plane of where the loop is? In other words, slanted the loop slightly, if it were a home application. Could that help?
Yes, of course. I mean, it might be, if you've got your favourite chair, you can use a chair loop. And if you use a chair loop, which is just a preformed loop that's like a cushion, you can then put that loop at whatever angle kind of suits your kind of position of the day.
You were pointing out that the latest televisions now are coming out, a lot of them with the optical audio out. If this is the case, is Apatotronic planning on having a direct connect from there to the amplifier instead of having to buy one of these off the market, off the shelf Jeffens or whatever they are?
Well, that question was actually asked earlier. I think the simple answer is that we don't have any plans yet because effectively the market isn't big enough to justify our development costs to do it. But ultimately, you know, if you guys keep asking us for it, we will do it, of course. Thanks for listening.